This is a video tutorial about deploying a real-time online endpoint that for a model that was produced with Automl and refers to forecasting. This is a public repository that's available at the URL you'll find in the description. And if you download this repository and you execute it as is, it deployed an endpoint and then I deployed the online deployment, and this has created this public endpoint, which then has your deployment name as a deployment. You will see that everything works fine, and I can even go on testing and I can request for a forecasting in the future, and it should give me the value that I was looking for and also the intervals, that the quantiles that I asked. This works great when you have a workspace that is public accessible and has access to the internet, but when you are behind a virtual network and you have a network isolation, things need to change a little bit. So for that, I would like to point you out that first and foremost, this is a preview feature, and I would like to point out one of the key limitations, which is that you need to disable the V1 legacy mode. This means that you will need to run a Python code in a notebook, which basically disables the V1 legacy mode. Having said that, this is my private endpoint protected workspace where I have all the resources and all the private endpoints that are described in the documentation. I'm connected through that through a VM and through Bastion, and this is Bastion host, and over here menu bar of the Bastion host, and over here is my host. So what I'm gonna do is I'm gonna go in full screen, and then I'm gonna switch to the Bastion host. So right now I am inside the virtual network. Over here I have my Azure ML private link protected workspace, and I have over here a command line. I have already cloned the repository, the public repository that we were talking about, and as you can see, if I click Git status, there is no modified file or anything here. I'm gonna be going through the README file, and basically I'm gonna start with the endpoint. So the very first thing that I will need to do is to create an endpoint that has no public access. So I'm gonna just save this. I'm gonna just comment this comment over there, and then I'm gonna run azml online endpoint create, and then I'm gonna pass the endpoint.yaml file. If I wanted to change the name, then I can use the set, and then I can put name equals, and in my case I want to keep the name that I have, so I'm gonna keep your endpoint name, so I'm gonna just keep that. In your case, endpoint name needs to be unique within a region. So this means that if you're deploying West Europe, where I deployed this, you probably won't be able to use the same endpoint name. The endpoint got deployed. So this means that if I go over here to my endpoints, I will see the fresh deployed your endpoint name. And as you can see, I have no deployment. So let's move to stage 2, which is basically the deployment. So a deployment is basically over here. I need to modify the endpoint name. If you change your endpoint name, you can either override it here on the file, or you can use the ---- set option. In order to make a deployment, I will need to disable the ingress to public network access. And what I have to do is I have to, instead of pulling the Azure ML AutoML image, I will have to use the cloned AutoML one, which is basically something that is created using the step 10 clone AutoML script. What this script does is that it connects to the workspace, it grabs the Azure ML AutoML environment that we provide for all Azure ML AutoML deployments, and it just clones it and stores it as a cloned AutoML. This will appear over here in the environments, and you will see it as this. And basically it's an MCR image with a couple of conda packages. I'm going to be deploying as a standard DS2 v1 and I only need a single instance. Regarding the scoring file and the model, these are files that already exist inside the GitHub repository, but these were actually copied from an AutoML experiment. If you would like to produce your own model and scoring file, you just need to run the step 020, which is basically going to generate a random dataset that starts on 2020 and it's going to create 36 hours for 36 records for 1 hour each, and it's going to just register this time series dataset as a time series underscore ds. So basically, if I go over here to my data, you will see the time series ds, and over here you will see the values that have automatically been generated. And it's nothing more than a date and the total order quantity of a specific product that I want to predict. And what I did is I went over here to the AutoML. I just started an AutoML wizard. I selected the time series dataset, and I have already created a new experiment like this time series experiment. I selected that I want to predict the total order quantities, and then I just select one of my clusters. AutoML automatically detected that this is a time series, and then next, and that was it. And the result was this experiment that has already run. And in here, you will see that I have some models. And for example, the best one model has some explanations attached to it. But I just entered a single model and then I went into the output and logs. And in here, I opened the outputs folder, and from here I just selected the model.pickle and the scoring file v2. So these are the two files that I copied, and then I uploaded the model here on the model folder and the scoring file here on the score, exactly as is. In fact, I think that the scoring file, I just run it through black so that I can format it, nothing more. I have already fixed the deployment.yaml file, so I can go back and run azml online deployment and then create a new one with -f and then the deployment.yaml. And this will take some time, so I will fast forward the video for you. Deployment has completed, so this means that if I go back over here to the endpoints, I will see my endpoint, and now I have a deployment. So basically I can start now testing and consuming the deployment that I have. Over here, you will be on the consume, you will find the primary key and the secondary key that we will need in order to make an inference. And if I basically go into the README file, I will find over here a sample of a curl command that I will need to test my endpoint. So basically, I'll need to send JSON, which is the input that I created. Make sure that the date is in the future of what you used to train, otherwise it will complain. And over here, you can specify the quantiles that you want to get as a response. And over here, we have the key from the portal. So if I go over here to the endpoint and go to the consume, I can copy either the first key or the second key, and I can paste it here. The reason why we have two keys here is that if you have applications that rely on this, you can configure them to start using the second key, and then you can come here and you can generate a new primary key and then grab that new primary key and configure it back into your own, to the services that are consuming this service. And this is how you will be able to rotate the keys every 3 months, 6 months, depending on your security requirements. And over here, I will need to specify the deployment name. In this case, it's called your deployment name, so I'm gonna keep it as is. And here is the endpoint, which I can just copy from here and paste it here, because you will see that although it is named your endpoint name, over here in the example I have region instead of West Europe, which is the region where I have deployed. So let me go back into my notebook and go inside my compute instance, which is inside the VNet where this online endpoint is exposed. And so I can, the DNS can resolve the endpoint, and I can route traffic to it. And if I try this out, I can see that the forecasting result is actually 20, and these are the prediction intervals that I requested for. This is how an online endpoint can work behind the VNet. I wanted to highlight a couple of things. So first and foremost, I would like to show you the version of Azure CLI that I have, and I'm running on the latest version of 2.38. If you need to upgrade, you just need to type AZ upgrade, and this will allow you to upgrade the packages. Hopefully you already have required access to do that behind the VNet. Firewall is allowing you that. For Azure ML, the extension, you need to run AZ extension add, and then just put name ML, and then does upgrade. And what I found is that in my setup, I had to manually go into the firewall and into my firewall policies, and I had to add the AKA MS redirection service that we have in Microsoft, so that the CLI could actually get redirected to where the latest version of machine learning extension is located. Thanks for watching, and leave any comment if you would like to see something more.